Welcome to episode 1 of creating your own operating system. In this episode I will show you how to install the virtual machine QEMU, and how to install NASM assembler. We can then create a bootloader that displays Hello World to the user. So let's get started. To download QEMU, go to the official website, link will be in the description. Click on the download button in the top right. Then select whatever platform you are currently running, although this tutorial will be more focused for Windows users. Select 64-bit. Then wait for the download to finish. I have already got it installed on my computer, so I will not show the process here, but it should be self-explanatory. Now, go to the official NASM website and click the download button in the top right. Select the newest version. Select Win64. Click on the install to install it. Once it has installed, run it. I recommend keeping the default installation path as it will make it easier to follow along with the tutorial. Once you have installed both NASM and QEMU, we can begin to write the bootloader. I am using Notepad++, but you can use any text editor you want. Here I am creating a folder called build. This is where the assembled bootloader will be written into. I then create bootloader, ASM and run .cmd, which we will use to assemble and run our bootloader. Drag them into Notepad where we can begin to write the bootloader. When a computer boots, it will load 512 bytes from sector 1 to address 0x7C00. We must then tell the assembler that our code is going to be located there. For backwards compatibility reasons, computers will always boot in 16-bit mode, and so we must tell the assembler that this is the mode our code is running in. Even though it is 16-bit mode, you are still able to use 32-bit registers, although you will still be limited on how much memory you can access. To make sure our bootloader works when we try it on real hardware, you must include the BIOS parameter block. If this is not included, your code may not work when you try and boot of a USB stick. Use a jump instruction to jump over the BIOS parameter block. Then create a main label and use jump $. The $sign represents the current memory location, and so this will create an infinite loop. We will then tell NASM to pad the rest of the file, apart from the last 2 bytes, with all zeros. This is done so that the bootloader is exactly 512 bytes. Then we will add the boot signature. The computer will only boot when it reads this specific signature. Now that we are done with the bootloader, we can begin writing the CMD file. Put the path to your NASM executable with the following parameters. Next, put the path to your QEMU executable with the following parameters. Put pause so that if there is an error, the window will remain open so you can read the error message. We are now ready to run. You can see the QEMU window pop up and no error have occurred. Our bootloader is not doing very much because it is stuck in an infinite loop, so next we are going to get it to display a character. We are going to create a function called printChar. We are going to use the interrupt 16, which can perform many different tasks. To specify which task we want the interrupt to perform, we put a specific number in the AH register, in this case 9. BH will store the page number. Page number can be used for double buffering, but we don't need that here, and so we'll just use page 0. CX stores the number of times we want to display the character, so for now this can be 1. AL stores the ASCII value for the character we want to print to the screen. The instruction 9 allows us to specify the foreground and background color of the character, with the 4 high bits representing background and the 4 low bits representing foreground. Then all we have to do is call the interrupt and return from the function. Before we call the procedure, we need to set up some stuff. We are going to set some of the segment registers to 0. The segment registers are used as offset in some instructions. Because we don't need these offsets, we can set them all to 0. Next, we are going to clear the direction flag using the CLD instruction. All this means is that when the processor is performing a string manipulation instruction, the processor will know that the string is stored in ascending order rather than descending order. Lastly, to be able to call the procedure, the stack needs to be set up. As the stack grows downwards, we can put it where the bootloader starts. Running the code, you can now see a capital H has been displayed and all the colors are showing correctly. I recommend you try yourself to get the whole hello world to display. We will do this and set up disk reading in future episodes, so you should subscribe.